In this video, we're going to do two AP problems in logarithms. The first one says, consider the functions of f and g given by f of x is equal to log base 10 of x minus 1 plus log base 10 of x plus 3, and g of x is equal to log base 10 of x plus 9 in the xy plane. What are all x coordinates of the points of intersection of the graphs of f and g? Now this problem is challenging in many ways, but nonetheless we'll just get through it. So we want the intersection, the points of intersection. So we want the x coordinates, but anyways we have to have the points of intersection in the first place. So we can set up an equation, which is that f of x, we can first write f of x is equal to g of x. Right, and then if we just plug these values in, we know that log, so we know that log x minus 1 plus log x plus 3 is equal to log x plus 9. We don't have to write the base because the base is 10. So we have this equation. So how do we solve it? Like, we have some random functions of logs here, but we can use the addition rule. So what's the addition rule? It basically says if you add two logs with the same base, so for example, log base 10 x minus 1 plus log base 10 x plus 3 is just log base 10 x minus 1 times x plus 3. Like that. And that's equal to log base 10 x plus 9. Okay, so therefore, now these two logs are the same, and they have the same base, meaning that these two numbers on the top are the same. So we can write this as a simple equation without any functions. So that is equal to x plus 9. We can expand the left-hand side. It gives us x squared minus 2x. No, wait, x squared minus x plus 3x minus 3 equals x plus 9. And then we minus x, so we minus 2x plus 3x, or we add x. So essentially we add x because this is minus 2x, and we move x to the other side. So we add x, and then minus 12 equals 0. So we have x squared plus x minus 12 equals 0. We can just factor this. So we can factor this using cross factor, so like that. So we have x plus 4 times x minus 3 equals 0. This means that x is equal to negative 4 or 3. Now this is the answer to this question, but so this is the answer to this equation here, but it's not the answer to the problem, which is why this part is challenging, because we have to figure out, so we have to remember to plug these in, the x's into the values of our equation here with the log functions to see if they actually are appropriate. So for f of x, if we just plug x equals negative 4 in, f of x equals negative 4 is, so f of negative 4 is going to be log, so negative 4 minus 1 is negative 5, plus log negative 4 plus 3, which is negative 1. Now this looks okay, but there's a problem here, which is that this part of the log cannot be negative. It has to be positive, you know? It has to be positive because here the base is 10, right? So I'm going to ask you a question. So this is essentially asking 10 to the power of what? So 10 to the power of x is equal to negative 5. Now what is x, right? So x is just for the log. So what is x? Well, there's no value for x. X is like physically unapproachable. There's no 10 to the power of x that equals negative 5. So this is just impossible to achieve. So this doesn't make sense after all. So x equals negative 4 doesn't work. So about x equals 3. If x is equal to 3, we have f of 3, which is log 2 plus log 5. Right, okay, so that looks okay. And then g of x is equal to log 3 plus 9, which is log 12. So those are all okay values. Well, they're appropriate, they're in the range, they're in the domain of log functions, so they're okay. So the answer is only going to be x equals 3, not x equals -4 or 3. Moving on to the second problem, two function models k and m are constructed to represent the scales of a product at a group of grocery stores. Both k of t and m of t represent the sales of the product in thousands of units after t weeks for t greater or equal to 2. If k of t equals 14 minus 2.885 times the natural log of t, and m of t equals -t plus 14, what is the first time t that the cells predicted by the logarithmic model will be 0.1 thousand units more than cells predicted by the linear model? In order to do this problem, we have to write an equation. So the last sentence says that the logarithmic model, k of t, is 0.1 thousand units more than the linear model. So we want t when this happens. So let's just plug in the values for k of t and m of t. This gives us 14 minus 2.885 times the natural log of t equals 0.1 minus t plus 14. So I found an online graphing calculator, and what we do is we input the line to the equation, y1 and y2, for the two sides of the equation. So y1 is equal to 14 minus 2.885 times the natural log of t. So that's our graph. Then y2, not the other equation, the linear model of our sales products is -t plus 14. That's our second model, right? However, we want to figure out t when the second model, when the linear model is 0.1 thousand units less than the logarithmic model. So we have to add 0.1 to this so that y1 equals to y2, so that these two equations are equal. So we add that, and what do we get? We get two points of intersection. So which one's correct? Is it 1.80706 or 4.32449? Now we're looking only at the x values because t is the x values, and the y values we don't really care. They're the actual cells, but we don't really care about those. The question asks us for t. Now the second one, 4.32449, is the correct t because in the problem it says that t is larger or equal to 2. So our answer to the problem is 4.324 if we round it to the nearest thousandths of the decimal place. So thanks for watching. Bye.